Hey, welcome back to your favorite trig class. Let's look at this example for finding exact values given a value and the sine of another. So I always like to make these visual if possible, given that the sine of theta is a third. So you know your sine is not just a third, but it's also telling you it's positive. So since the fact that it's positive, I know I'm either in quadrant 1, because remember the sine is the y value. Y value is positive in those two quadrants. And then it tells you this is in cosine, this is in the quadrant where a cosine is negative, and your cosine is negative in quadrant 2 or quadrant 3 is where your x's are negative. So you know it's got to be drawn into quadrant 2. So that's our first step here is I'm going to draw this thing and be like, okay, let me draw this rotation in to quadrant 2. Here's my theta, okay? That's my angle. Now I know that the sine of theta is a third, and so I'm going to revert to my right triangle trigonometry, knowing that the sine of theta is a third. Remember, a sine is opposite over hypotenuse. Now I kind of have to jimmy rig this. This was at the end of section 6.2, where I'm using my reference angle, because for right triangle trig, SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. That only works for the first quadrant, right? So we have to jimmy rig it, and we just say, well, it's the second quadrant because, and I can still use these properties of right triangle trig. I can create this right triangle and use this reference angle theta prime. I just know that my cosine, my x value is negative there, okay? And I'll be able to create this triangle, put these values in, and actually answer the question using right triangle trig for a value that's greater than 90 degrees, okay? So that's what I'm going to do. So I say, all right, I'm in quadrant 2. That's my first thing. I draw this thing. Where is this at? I then think about the given information. The sine is 1/3. So I'm using the reference angle. So the reference angle is between the terminal side of the angle, right? Here's the terminal side. I go straight back down and I create the 90, so it's right in between there. That's my reference angle, theta prime. Okay, so it's between the terminal side and the x-axis. That's where theta prime is. If it would have rotated into quadrant 3, then I would draw it straight back, and theta prime is right here, even though theta is that entire angle. But theta prime is right in there. If I'm drawing my reference angle into quadrant 4, there's theta. I create the right triangle by going straight back to the x-axis. There's my theta prime right there. Okay. If I'm in quadrant 1, it's way easy. Theta is theta prime because I meet the requirement for right triangle trig, right? It's just right between. I can still create the right angle, and theta prime is already between the terminal side and the x-axis. Okay. Alright, so let's get back to this here. So we have the fact that the sine of theta is 1/3. So if you're looking at this, right, I'm looking at this triangle here now. And I say this is my opposite side of theta prime. This is my adjacent side. And this is my hypotenuse. And this is saying that my opposite side is 1. My hypotenuse is 3. 1. My hypotenuse is 3. So my step 1 is I'm drawing it. Step 2, I'm going to label the triangle on this thing using my right triangle trig. 3, now I have a right triangle, so I'm going to say, well, I know a squared plus b squared equals c squared, where c is my hypotenuse. A and b are my legs, so I got 1 squared plus b side length, and again, I don't know the b, that's my adjacent side, I don't know, I'm going to solve for that, equals my hypotenuse, which is 3. So 1 squared is 1, subtract 1 from both sides, 3 squared is 9, so 9 minus 1 I get 8, square root, so b is plus or minus, of course this is 4 times 2, in other words, plus or minus 2 root 2, okay? Now which one is it? Well, b, remember we said in quadrant 2 our cosine is negative, so what this is where the Jimmy rig, if you will, comes into play. I call it Jimmy rig in this because I'm using right triangle trig, but I have an angle. Remember, my original angle theta is bigger than 90 degrees. I'm just using theta prime to do this. So I have to use for my b, when I'm finding these other trig functions, I'm going to have to label b here as negative 2 root 2. I'm going to label it negative because because my cosine is negative. Otherwise, when I do the right triangle trig for this, it's not going to work. Okay, because I already know my sine is 1/3. My cosine of theta, remember cosine is adjacent over hypotenuse. So my adjacent side, remember I'm using theta prime, right? I'm finding the cosine of theta, but I'm using theta prime right here. So the adjacent side is that negative 2 root 2 over 3. That's my cosine because I've labeled my triangle. My tangent is opposite over adjacent. So the opposite side is 1. The adjacent side is negative 2 over 2. Negative 2 root 2. So negative 1 over 2 root 2. And I go ahead and rationalize that. So I got negative root 2 over 2 times 2, which is 4. Now I just do the reciprocal. So cosecant, instead of 1/3, I got 3 over 1. Secant, instead of negative 2 root 2 over 3, I got, flip it around, and then cotangent. So I got negative 2 root 2 over 1. Okay? That's how you find the 5 remaining trig functions for that. Now we're going to repeatedly do this process and throughout the course, so you want to get good at this. Your textbook, your authors will call this option 1. There is another option for doing this, but it's kind of like sometimes I'll have students, well, why don't you just do it the easier way? Well, you want to be able to use all the different tools in math. Like you're not always using a flathead screwdriver. You want to be able to use a Phillips screwdriver because sometimes a Phillips screwdriver is more appropriate for whatever purposes you're wanting the tool for. So same thing here. So even though sometimes this will look a little complex right now, this is frankly probably the best tool. But sometimes you can use these identities to solve these as well. So here's the same problem, just a different approach, and you'll be able to see the connections here. So we're going to solve this using the identities. So first of all, I'm like, okay, I know my little hint here is let's use the money formula because I have the sine of theta, and if you remember, you want to think, well, the sine's positive, so I'm either here or here, but then the cosine's negative, so since the cosine's negative, I'm either in quadrant 2, right, because of that, or I'm in quadrant 3. So they both have to occur, so it's got to be here in quadrant 2. So I know this thing has rotated into quadrant 2, right? So you want to think about that prior to even starting using the identities, right? Because your x will be negative, your cosine will be negative, your sine will be positive, right? All right, so let's do that now using the identities. So I know sine squared plus cosine squared equals 1. I know the sine of theta. Remember, sine squared theta is just sine theta times sine theta. There's 2 of those, right? That's what sine squared theta is. So you got 1/3 sine of theta squared. I subtract, that's 1/9. So cosine squared theta is 9/9 minus 1/9. I got 8/9. I'm going to square root both sides. So cosine theta is plus or minus square root of 8, 2 root 2, square root of 9, 3. Now, which one is it? Well, we're like, well, we already know cosine theta is negative. It's in, this thing's in quadrant 2. So I know my cosine has got to be the -1. Alright, so now we got sine, we got cosine. Now we can do tangent, which is sine over cosine. And we could do all the reciprocals just like we did over here, right? Do all the reciprocals now as well. All right, let's do some more. Got to get back to my lovely blue. Given that the tangent's root square root of 3 over 3, sorry, I can't talk, and the sine is negative, find the exact value of each of the remaining trig functions. So let me think about this first, right? Let me think about this. Okay, tangent's positive. Where is the tangent positive? Remember, tangent is, if the tangent is positive, right, sine over cosine is positive, that means either they're both positive, sine's positive and the cosine's positive, so it could be in quadrant 1, or it could be a negative over a negative. That's still positive, right? So sine over cosine, so a negative over a negative would be a positive. So you could be in quadrant 3. That meets the requirements for the tangent being positive. But then they also give you the information that, hey, your sine is negative. That means if your sine's negative, you're either in quadrant 3. Whoops, that's 3, not 4. Sorry about that. 3. Or you're in quadrant 4 if your sine's negative, right? Your y value. So where do they both occur? Quadrant 3. So we know this thing rotates into quadrant 3. This is driving me nuts. I've already made a mess of this thing. Rotates into quadrant 3. Okay, here's our theta rotation. Now, here's where we're going to use our right triangle trig, right? We're going to do this setup here. We know that, remember, SOHCAHTOA, sine is opposite over hypotenuse, cosine, or oh heck, another hour of algebra, right? Tangent is opposite over adjacent, right? So I'm going to go ahead, draw my right triangle, name this is theta prime, right? I got to use my reference angle to do this with right triangle trig. With respect to theta prime, that would then be my opposite side. This is my adjacent next to, because this is my hypotenuse right there, opposite the 90 degree. So the opposite side is root 3. The adjacent side is 3. Now, you got to be careful. X is negative, right, because we're using the reference angle for an angle bigger than 90 degrees. So I got to jimmy rig this. X is negative, right? I'm going negative X. I'm going negative Y. So my Y is negative. Make sure you make the X negative, the Y negative, so that when you do the other trig functions, this is properly done. Okay. So we draw it. We label our, so number 1 we draw it. Number 2 we label our right triangle. Number 3 we solve for the hypotenuse in this case. So a squared plus b squared equals c squared. Again, I know that those are distances, but you can ignore that because they get squared anyway. So 9 plus 3 equals c squared. So c squared equals 12. In other words, square root, c equals plus or minus 2 root 3. Now the hypotenuse is always positive, right? That's your radius of this circle, right? Because it's rotating and hitting that spot right there. So your hypotenuse, 2 root 3. Now, I can do everything. I can do everything. Sine is opposite over hypotenuse. the opposite side, negative root 3, hypotenuse to root 3. The root 3's cancel, leave us negative 1/2. Cosine adjacent over hypotenuse, negative 3 over 2 root 3, multiply top and bottom by root 3, so negative 3 root 3 over 6, that cancels and gives you negative root 3 over 2. Tangent, we already have that, that was given to us. Now I'm going to do my reciprocal. Cosecant, the reciprocal of the sine. So instead of negative 1/2, negative 2 over 1, negative 2. The secant, negative 2 over root 3, so negative 2 root 3 over 3. Cotangent, 3 root 3 over 3, because I flipped it around. I should have wrote that, sorry. 3 over root 3, and then I rationalize it, 3 root 3 over 3, which is just root 3. Okay? Alright, our even odd properties here. Our even odd properties. So if you remember from pre-calculus, an even function like y equals x squared, right? The parabola y equals x squared satisfied this property. Whereas an odd function satisfied this property. Most people think of a very poorly drawn y equals x cubed, right? So the even ones here, like sine of negative theta, let me give you an example. Like sine of negative pi 6. Oops, negative pi 6. If you go down 30 degrees to right here, this is saying that's the exact same thing as the negative sine of pi 6, right? That's what this is saying. It's saying that, hey, this is an odd function. F of negative x equals the opposite of f of x, right? In other words, if I go positive pi 6, negative, what's the sine of pi 6? What's the sine of pi 6? It's just a half, but you have the negative in front. What was the sine of negative pi 6? We know the sine of negative pi 6 is negative a half. You see that? So the sine function is odd. Notice the tangent function is odd. So are their reciprocals. Whereas the cosine is even, and its reciprocal is secant. For example, the cosine of, well, I'll do it with the same one. Let's go negative pi 6. The cosine of negative pi 6 is root 3 over 2. This is root 3 over 2. And this is saying it's the exact same thing as the cosine of pi 6. Well, here's our pi 6. What's the cosine of that? Root 3 over 2. Sure enough. Right? Those are both there in that quadrant 1 and quadrant 4 for this one. Quadrant 1 for that one. Your x values are both positive there, and you know it's the same value. So that is an even function. So you can use those when you're working problems. Those are helpful. We'll actually revisit this in more detail when we do graphing these trigonometric functions. But let's look at these here. So find the exact value of each of the following. Well, according to the last slide there, the sine of negative 30 degrees, and I know you can just do it, right? You can just say, well, negative 30 degrees is right here. what's the sine? Yeah, it's -1/2. But you can also use the property. Sine of negative theta is negative sine of theta. So this should be negative sine 30 degrees. Negative. So you find the sine of actually 30 degrees. Alright, see, it's the same thing. Either just do it, find it, or use the property with the negative out front because it's an odd function, and then find the sine of the positive value, right? So either one of those is fine. I really don't care how you approach that, but just be aware of those properties. Cosine negative pi thirds. You say, well, let me rotate negative 60 degrees, negative pi thirds, and let's just do it. Let's just do it, and then we can also do it with the properties. But you're right here at 1/2 negative root 3 over 2. What's the cosine of negative pi thirds? Well, we know it's a half, right? Or you can say cosine negative pi thirds, because this is an even function, is the exact same thing as the cosine of pi thirds. So if I do it that way, then I'm just looking at pi thirds, and I know that my cosine is positive 1/2, right? Either way, and you could continue on doing it similar to that. Okay, let's finish up. Let me erase these here real quick. I'll finish these out. These last two. Cotangent, -5 pi force. So I'm going to go around negative pi minus pi force more, so there's your -5 pi force. The same thing as negative 225 degrees. And you're right here. And you say the cotangent's the reciprocal of the tangent. Remember, tangent sine over cosine. So cotangent's cosine over sine. So cosine there, negative root 2 over 2. Sine right there, root 2 over 2. Looks like we got -1. Last one, tangent, negative 29 pi force. Oh my goodness. Well, that's one time around. There's -2 pi. There's 2 pi, another revolution around. So that's -16 pi force. I could go again. There's 3 times around, -24 pi force. There we go. 24 minus 5, -24 minus 5, -29 pi force. So I'm going to go around negative direction. 1, 2, 3, and then 5 pi force. So I'm actually to that same spot from that last one, right here. So what's the tangent there? Sine over cosine. -1. All that work for -1. Well, appreciate you guys listening and learning. Good luck with that homework. Talk to you later.